Given two fixed points f1 and f2, these points are symmetric about the origin, and for now assume that they lie on the x-axis. The collection of points whose sums of the distance from the first focus and from the second focus, that sum of the distances, if this is constant, then the collection of points form an ellipse, and in this case we call f1 and f2 the foci. Thus, if the point P has the coordinate x, y, then the sum of the distance from P to f1 plus P to f2 has to be constant for any other arbitrary point on this ellipse. In mathematical expression, this means P of f1, that is the distance from the point P to f1, plus P of f2, that is the distance from the point P to f2, is always a number, a constant. In this case, we were told to use 2a. We need to find the equation for the ellipse. The distance from the point P to f1, using the distance formula, we have the distance squared equals x minus negative c squared. This is y2 minus y1 squared plus y minus 0 squared. This is distance 1, P f1. The distance from the point P to the point f2 squared is x minus c squared plus y minus 0 squared. And since we were told that the two distances add up equal to a, we must have the square root of the first distance. We simplify this as x plus c squared plus y squared plus the square root of the second distance, which is x minus c squared plus y squared, equals 2a. To simplify this, we first need to isolate one of the squared. If we keep the square root of x plus c, the quantity squared, plus y squared on the left hand side, then we have 2a minus the square root of the quantity x minus c squared plus y squared. And we then square both sides of this equation. If we square the left hand side, then the square root and the square canceled out, leaving us with x plus c, the quantity squared, plus y squared. Using the identity, the square of a binomial on the right hand side, we have 2a squared minus 2 times 2a times the square root of x minus c squared plus y squared plus the square root of x minus c squared plus y squared squared, and this square root and then the square canceled out, so we have x plus c squared plus y squared equals 4a squared minus 4a times the square root of x minus c squared plus y squared plus x minus c squared plus y squared. And then we combine like terms. Observe that there's a y squared on the left and a y squared on the right, so we cancel this out. We expand x plus c squared and x minus c squared. The left hand side is x squared plus 2 times x times c plus c squared. And the right hand side is 4a squared minus 4a times the square root of x minus c squared plus y squared plus x squared minus 2 times x times c plus c squared. And so c squared canceled out, x squared canceled out as well. We then move the term with the radical to the left-hand side to obtain 4a positive, the square root of x minus c squared plus y squared equals, on the right-hand side, we have 4a squared minus 2xc, and the 2xc on the left moved to the right-hand side, which is minus 2xc. We can combine like terms again. For a, the square root of x minus c squared plus y squared on the left-hand side. The right-hand side is 4a squared minus 4xc. We then divide by 4 both sides of the equation to have a times the square root of x minus c squared plus y squared equals a squared minus xc. We then square both sides again. The left-hand side is now a squared times x minus c squared plus y squared, but this should be in the bracket, equals a squared minus xc, the quantity squared. We then distribute the right-hand, the left-hand side, a squared times x minus c squared plus a squared times y squared. This is why we need that bracket. The right-hand side is a to the fourth minus 2 times a squared times xc plus the quantity xc squared. The left-hand side is a squared times x squared minus 2xc plus c squared plus a squared y squared. And the right-hand side is a to the fourth minus 2a squared xc plus x squared c squared. This is a squared x squared minus 2a squared xc plus a squared c squared plus a squared y squared equals a to the fourth minus 2a squared xc plus x squared c squared. And we see that there are two like terms, minus 2a squared xc and minus 2a squared xc, and so they canceled out because they are on both sides of the equation. If we were to add one, then they canceled out. And so we end up with a squared x squared plus a squared y squared minus x squared c squared equals a to the fourth minus a squared c squared, where we bring all of the terms with the variable x and y to the left-hand side and all of the constant terms to the right-hand side. Rearranging this, we have a squared x squared minus x squared c squared plus a squared y squared equals, we factor out a squared on the right-hand side, we end up with a squared minus c squared. We then factor out x squared to get a squared minus c squared times x squared plus a squared times y squared equals a squared times a squared minus c squared. To obtain a useful equation, we then let b be a squared minus c squared. In this case, for this to work, we would need to have a greater than c. And so, this is now b squared times x squared plus a squared times y squared equals a squared times b squared. We then divide both sides of this equation by a squared b squared, the left and the right hand side. We then have x squared over a squared plus y squared over b squared equals 1, assuming that a is greater than b in this case. This is the equation of an ellipse.